This video is on two-column proofs. We're going to be doing two proofs on here. The first proof we're doing has how many statements and reasons we're going to have, but no information provided in our proof. And the last proof we're going to do has nothing given, no information for our proof, so we don't even know how many statements there are. So this one is going to be completely whatever you see. So on this problem, we know that there are going to be 5 statements. The first statement should be your givens. So our first given, it says C is the midpoint of BD and AE. So I need to write that into statement 1. C is the midpoint of segment BD and segment AE. I will abbreviate a little, but not much, and the reason is given. Now that's our only given, so statement 2 would go into our body paragraph. So before we go into that, we need to see if there's anything we can mark. C is the midpoint of BD and AE. There's no congruency symbols in here, so I can't write anything off to the side. That also means, though, I have to use my givens to get congruency. I have to use my givens. So in the given, there is a word that says midpoint. I know that midpoint gives me 2 congruent segments. That's what midpoint does. It cuts a segment in half. So the midpoint of BD is the first part, but then it's also midpoint of AE. So I have 2 different things that were midpoints. So that means I'm going to be using midpoint in my proof. If I see the word, I'm going to use that word. So midpoint. Let's focus on BD. BD is a line that has a midpoint. BD is cut in half. So the 2 segments that are created by being cut in half are the 2 little ones, which are segment BC and also segment DC. So we can say that segment BC is congruent to segment DC because that was the definition of midpoint. Definition, midpoint. Midpoint cuts 2 segments, it cuts a segment in half. So what that means is that we're going to end up having 2 segments congruent. Just from that one. Well, we're also going to we have midpoint of AE. That tells us the same thing. So we're going to have another set of 2 segments. So let's find AE, because that's the one we circled. From A to E. A to E is going to have a midpoint. That means that A to E is cut in half. So we're going to have 2 smaller segments that are created. And those will be congruent. So from A to C, segment AC is congruent to segment EC. And that was the definition of midpoint. So we've used all of our givens. We've used the midpoint of BD and the midpoint of AE. So let's go back to see if we have any congruency. We have congruent segment. So we can put an S beside number 2. Number 3, we have congruent segment. So I can put an S beside number 3. Now we need, because that was all from our given, we have to now look at the picture and find anything else. So in our picture, the triangles do not share an entire side, but they do touch at this point right here. These are 2 intersecting lines. That means we have angles that are congruent. This angle and this angle are congruent because they are vertical angles. Now, the angles on the outside are too, but they won't help us since they're not in the triangle. So we just need to name these 2 angles. Angle, I'm going to name the first one as ACB. As long as you put C as your vertex, you're fine. It's the way we name the second one that matters. A to C went over the 2 tick marks, so we need to do the same thing on our other one. It needs to go over the 2 tick marks. So I have to start with E. Angle ECD. Angle ECD are congruent because of vertical angles. Now that I have congruent symbol, and that's an angle, I have congruent angles, so I have an A. So again, we look at how many, we have 3 things, and our 5th one should be our conclusion. So we have SSA or SAS. So if we look at our picture, we know SSA can't work. So if we have SSA, we know these are not congruent. So we look at our picture, we have a side mark here, an angle, and a side. We need, since we have 2 sides, we want to go from side to side, but we have to go concurrently or consecutively. So if I go from this side down and over, I don't hit anything, so I can't use that. I have to go up and then back down to get to my side. So if I go up and then back down, I hit the angle. So if I go from S to S, if I hit the angle, that's what I want. If I go from S to S here, I don't hit the angle. So SSA is gone. So we know this is SAS. This one is good. This is SAS. Now let's look at this one. I have a side marking, an angle marking, and a side marking. I need to go from side to side, going as shortest way possible. So from side to side, I hit the angle arc. So I hit the A. So this is SAS as well. So our triangles are congruent by SAS. So our proof says prove triangle AEC. I apologize, that's ABC is congruent to triangle EDC, and the reason is side, angle, side. Our last proof we have to do all on our own, so that means we need to write out statement and reason. We do not know how many statements and reasons there are, so we're just going to make a 2-column. We're going to start. So statement 1, your first given, segment AB is congruent to segment CB. First reason is given. Second statement is your given. Segment BD bisects segment AC. Reason, given. Those are all of our givens. So now I'm going to look to see if I have any congruency. I have a congruent segment, so I can put an S. There's no congruent symbol. So I only have one thing. That means I have to use my given. So go back up to my given, to this given here. I see a word. It says bisects. Then I circled the next part. I want to focus specifically on AC. I can mark, real quick, the AB and CB. I can mark that because they are congruent with tick marks. So now I want to focus specifically on AC, from A to C. A to C is being bisected. That means I'm going to have 2 congruent, and since this is a segment, I'm going to have 2 congruent segments. That's what that tells us. Focusing on A to C, we break it up into 2 smaller segments. So we have A to D and C to D. So statement 3 would be AD, segment AD is congruent to segment CD, not DC, because A is on that 1 tick mark and C is on that 1 tick mark. So we start with CD. And that is the definition of bisect. Because it's not an angle, we can just say definition of bisect. If it was an angle, we would say definition of angle bisect. Now we can mark that. So segment AD is congruent to segment CD. That is congruent segment. Put an S beside it. I have now used the givens. So I've used all of the givens. We only have 2 things. 2 things are congruent, so now I have to look at the picture. On this picture, these triangles are actually sharing this entire side. That would be congruent to itself. So statement 4, BD is that segment that they're sharing. So BD is congruent. Now, again, the first way you name it, just name it. It's the second way you have to correspond. So I started with B. If I start on this triangle at B, that has between the 1 tick mark and then there's no tick marks here. So B is between one tick mark and no tick marks. So on this triangle, here's my one tick mark, here's my no tick marks. The letter between those is also B. So segment BD is congruent to segment BD. And that is called the reflexive property. So now I can mark it, and because it's congruent segment, I put an S. SSS. That is the only thing that we could try and prove. And so we look, do we have the same amount of tick marks? We do. So these two triangles are congruent. So statement 5 is triangle ABD is congruent to triangle CBD by side, side, side. This entire proof was done without any knowledge of how many statements there were. We did it in the quickest way possible, and we had no information inside the proof to help us. That is a formal proof, a 2-column formal proof.